In an extension cord, there are three conductors: a hot, a neutral, and a ground. The hot carries the current from the power source to the powered device. The neutral carries the current back to the power source, completing the circuit. The ground provides a path for fault currents to flow to the ground and prevent electrical shock. Metal-clad and Romex cables are used in permanent wiring installations. They contain multiple conductors within a single sheath. In the case of 14/3 metal-clad or Romex, there are two hots. These carry the current to different circuits or loads. One neutral serves as the common return path for both circuits. Metal-clad and Romex cables typically require a separate ground wire to be installed alongside them. The primary reason for the difference is the intended use and safety considerations. Since extension cords are often used in temporary applications, such as powering appliances or tools, they need to provide grounding for safety. The ground wire protects against electrical shock if the hot wire accidentally comes into contact with the metal casing of the device. In permanent wiring installations, the ground wire is typically run separately from the circuit conductors within the wall or conduit. This is because it is more efficient and cost-effective to bundle multiple hots and neutrals together within a single cable while providing a separate ground wire for safety. Extension cords require a ground wire for immediate safety, while permanent wiring installations such as metal-clad and Romex typically have a separate ground wire run alongside the circuit conductors for overall safety. To further clarify, firstly, an extension cord is designed for temporary use, plugging in portable devices. Its grounding conductor provides immediate protection against faults in the connected appliance. Secondly, metal-clad and Romex are for permanent building wiring. Grounding is handled by a separate ground wire or the metal conduit system, offering continuous protection for the entire electrical system. The National Electrical Code, also known as NEC, dictates the standards for safe electrical installations. It covers aspects such as wire sizing, overcurrent protection, and grounding requirements. The NEC addresses both temporary and permanent wiring methods, ensuring that safety is maintained in all electrical systems. Consider an appliance with a metal casing. If a hot wire inside the appliance comes loose and touches the casing without a ground wire, the casing becomes energized, posing a shock hazard. With a ground wire, the fault current flows through the ground wire back to the source, tripping the circuit breaker or fuse and cutting off the power. In a permanently wired building, the grounding system is more comprehensive. It includes grounding electrodes, bonding conductors, and equipment grounding conductors. This system ensures that all metal parts of the electrical system are at the same potential, minimizing the risk of shock. The resistance of the grounding path is crucial. A low resistance path ensures that fault currents can flow quickly and reliably back to the source, tripping the overcurrent protection device. The NEC specifies maximum allowable resistance values for grounding systems. Proper grounding is essential for safety and preventing electrical fires. Regular inspection and testing of grounding systems are recommended to ensure their effectiveness. Extension cords are typically rated for specific ampacities. Exceeding the ampacity rating can cause the cord to overheat, potentially leading to a fire. Always use extension cords that are rated for the intended load. Metal-clad and Romex cables also have ampacity ratings, which are determined by the size of the conductors and the insulation type. These ratings must be followed to prevent overheating and fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring from overloads and short circuits. These devices must be properly sized to match the ampacity of the wiring they protect. Ground fault circuit interrupters, also known as GFCIs, are designed to protect people from electrical shock. They detect small imbalances in current between the hot and neutral conductors and quickly trip the circuit. GFCIs are commonly used in bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, also known as AFCIs, are designed to protect against electrical fires caused by arcing faults. They detect abnormal arcing conditions and quickly trip the circuit. AFCIs are commonly used in bedrooms and other areas where fire hazards are higher. Consider a scenario where a nail is driven through a Romex cable in a wall. This could create a short circuit or an arcing fault. A circuit breaker or a fly would quickly trip, cutting off the power and preventing a fire. In a temporary wiring situation, such as a construction site, ground fault protection is often required for all 120 volts receptacles. This protects workers from electrical shock hazards. The NEC provides specific requirements for temporary wiring installations. These requirements address issues such as grounding, overcurrent protection, and the use of weather-resistant materials. Electrical systems must be properly maintained to ensure their safety and reliability. This includes regular inspections, testing, and repairs. Neglecting electrical maintenance can lead to hazards such as electrical shock, fires, and equipment damage. The voltage drop in a wiring system can affect the performance of electrical equipment. Excessive voltage drop can cause lights to dim, motors to run slower, and electronic devices to malfunction. The NEC provides guidelines for minimizing voltage drop. Proper wire sizing is essential for minimizing voltage drop and ensuring that electrical equipment receives the correct voltage. The NEC provides tables for determining the appropriate wire size for different loads and distances. The type of insulation used on a wire affects its ampacity and its suitability for different applications. The NEC specifies different insulation types and their allowable uses. The location of electrical equipment can affect its safety and performance. Equipment installed in damp or wet locations must be rated for those conditions. The NEC provides requirements for the installation of electrical equipment in different environments. Electrical boxes are used to enclose and protect electrical connections. They must be properly sized and installed to prevent hazards. The NEC provides requirements for the installation of electrical boxes. Conduits are used to protect wiring from physical damage and environmental factors. They must be properly sized and installed to provide adequate protection. The NEC provides requirements for the installation of conduits. Electrical panels are used to distribute power to different circuits in a building. They must be properly sized and installed to provide adequate capacity and protection. The NEC provides requirements for the installation of electrical panels. Grounding electrodes are used to connect the grounding system to the earth. They must be properly installed to provide a low resistance path for fault currents. The NEC provides requirements for the installation of grounding electrodes. Bonding conductors are used to connect different metal parts of the electrical system together. They must be properly sized and installed to ensure that all metal parts are at the same potential. The NEC provides requirements for the installation of bonding conductors. Surge protectors are used to protect electrical equipment from voltage surges. They must be properly installed to provide effective protection. The NEC provides recommendations for the installation of surge protectors. Uninterruptible power supplies, also known as UPS, are used to provide backup power during power outages. They must be properly sized and installed to provide adequate backup power. The NEC provides recommendations for the installation of uninterruptible power supplies. Generators are used to provide backup power during power outages. They must be properly installed to prevent hazards such as backfeeding and carbon monoxide poisoning. The NEC provides requirements for the installation of generators. Solar photovoltaic, also known as PV, systems are used to generate electricity from sunlight. They must be properly installed to prevent hazards such as electrical shock and fire. The NEC provides requirements for the installation of solar photovoltaic systems. Wind turbine systems are used to generate electricity from wind. They must be properly installed to prevent hazards such as mechanical failure and electrical shock. The NEC provides recommendations for the installation of wind turbine systems. Electric vehicle charging stations are used to charge electric vehicles. They must be properly installed to prevent hazards such as electrical shock and fire. The NEC provides requirements for the installation of electric vehicle charging stations. In summary, understanding the differences between extension cord wiring and metal-clad or Romex wiring is crucial for electrical safety. Extension cords prioritize immediate grounding for temporary applications, while permanent wiring relies on a comprehensive grounding system installed alongside the circuit conductors. Always adhere to the National Electrical Code, and known as NEC, requirements, and consult with a qualified electrician for any electrical work. Remember, electrical safety should always be a top priority. For example, consider 120 volts, 15 amp circuit. Using 14 American wire gauge, also known as AWG, wire is generally acceptable for short runs, but for longer distances, a larger wire size may be needed to minimize voltage drop. The NEC provides tables to determine the appropriate wire size based on the load, distance, and allowable voltage drop. For example, NEC Table 310.15b16 provides ampacity ratings for different wire sizes and insulation types. It's crucial to consult these tables to ensure that the wiring is properly sized for the intended application. Consider a 240-volt circuit powering a water heater. Using 10 American wire gauge, also known as AWG wire, is often suitable for a 30 amp circuit breaker. However, the specific requirements depend on the water heater's wattage and the distance from the electrical panel. Again, referring to NEC tables is essential. Grounding electrode conductors connect the grounding system to the earth. The size of the grounding electrode conductor depends on the size of the service entrance conductors. The NEC provides tables to determine the appropriate size. Bonding jumpers are used to bond metal parts of the electrical system together, ensuring that they are at the same potential. The size of the bonding jumper depends on the size of the circuit conductors. The NEC provides tables to determine the appropriate size. When installing electrical equipment in wet locations, such as outdoors or in bathrooms, it's essential to use equipment that is rated for wet locations. This equipment is designed to withstand moisture and prevent electrical shock hazards. The NEC provides requirements for the installation of electrical equipment in wet locations. When running wiring through walls or ceilings, it's important to protect the wiring from physical damage. This can be done by using conduit or by ensuring that the wiring is properly supported and protected from nails or screws. The NEC provides requirements for the protection of wiring. When making electrical connections, it's important to use proper wiring methods and connectors. This ensures that the connections are secure and prevent overheating or arcing. The NEC provides requirements for making electrical connections. When working with electricity, it's essential to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. The NEC provides guidelines for safe work practices. Always double-check your work and ensure that all connections are tight and that the wiring is properly installed. A thorough inspection can help to identify potential problems before they become hazards. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. Consider a scenario where you're adding a new circuit to an existing electrical panel. It's important to ensure that the panel has sufficient capacity to handle the new circuit. If the panel is already full, you may need to upgrade the panel or install a sub-panel. The NEC provides guidelines for determining the capacity of electrical panels. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide specific information about the equipment's installation, operation, and maintenance. Ignoring the manufacturer's instructions can lead to hazards or equipment damage. Consider a situation where you're installing a new lighting fixture. It's important to choose a fixture that is appropriate for the location and the intended use. For example, a recessed lighting fixture installed in an insulated ceiling must be IC rated, meaning that it is designed to be in direct contact with insulation. The NEC provides requirements for the installation of lighting fixtures. Remember that electrical work can be dangerous. Always take precautions and follow safe work practices to prevent electrical shock, fire, and other hazards. If you have any doubts or concerns, consult with a qualified electrician. For example, If you're working on a 208 volts or 480 volt system, the risks are significantly higher than working on a 120 volt system. Higher voltages can cause more severe electrical shocks and fires. Therefore, it's crucial to have the necessary training and experience before working on high voltage systems. The NEC provides specific requirements for working on high voltage systems. Always use properly insulated tools when working with electricity. Insulated tools can help to protect you from electrical shock. The NEC requires the use of insulated tools when working on energized circuits. Never work on energized circuits unless it is absolutely necessary. If possible, de-energize the circuit before working on it. This significantly reduces the risk of electrical shock. The NEC provides guidelines for working on energized circuits. Always be aware of your surroundings when working with electricity. Avoid distractions and pay attention to what you're doing. A moment of carelessness can have serious consequences. The NEC provides guidelines for maintaining a safe work environment. Consider a situation where you're working in a confined space, such as a crawl space or an attic. These spaces can be dangerous due to limited ventilation, poor lighting, and the presence of hazards such as exposed wiring and sharp objects. The NEC provides requirements for working in confined spaces. Always wear appropriate clothing when working with electricity. Avoid wearing loose clothing or jewelry that could get caught on equipment or wiring. The NEC provides guidelines for appropriate clothing. Always inspect your equipment before using it. Check for any damage or defects. Do not use any equipment that is damaged or defective. The NEC provides guidelines for the inspection of electrical equipment. Always report any electrical hazards to your supervisor or the appropriate authorities. This helps to prevent accidents and injuries. The NEC provides guidelines for reporting electrical hazards. Remember that electrical safety is everyone's responsibility. By following safe work practices and adhering to the NEC requirements, you can help to create a safe working environment and prevent electrical accidents. For instance, understanding the difference between a series circuit and a parallel circuit is fundamental. In a series circuit, the current flows through each component sequentially, meaning if one component fails, the entire circuit is broken. In a parallel circuit, each component has its own path for current to flow, so if one component fails, the others continue to operate. This principle is crucial in designing and troubleshooting electrical circuits. Consider the application of Ohm's law, which states that voltage equals current times resistance. This simple formula, expressed as volts equals amps times ohms, is essential for calculating voltage, current, or resistance in a circuit. By understanding Ohm's law, you can determine the appropriate size of components and ensure that the circuit operates safely and efficiently. Remember that the NEC is constantly updated to reflect new technologies and safety practices. Staying current with the latest NEC requirements is essential for ensuring that your electrical work is safe and compliant. You can access the latest NEC through various sources, such as the National Fire Protection Association, also known as NFPA, website, or by purchasing a copy of the code book. Consider attending electrical safety training courses to enhance your knowledge and skills. These courses can provide you with hands-on experience and teach you how to perform electrical work safely and correctly. Many organizations offer electrical safety training courses, such as trade schools, community colleges, and professional associations. Always prioritize safety when working with electricity. Electricity is a powerful force that can cause serious injury or death. By following safe work practices and adhering to the NEC requirements, you can minimize the risks and protect yourself and others from harm. For example, when working on a circuit, always use a voltmeter to verify that the circuit is de-energized before touching any wires or component. A voltmeter can accurately measure the voltage in a circuit and confirm that it is safe to work on. Consider using a clamp meter to measure the current flowing through a wire without having to break the circuit. A clamp meter can be clamped around a wire and will display the current reading. This is a useful tool for troubleshooting electrical problems and verifying that circuits are operating within their rated capacity. Remember that electrical codes and standards vary from location to location. Always check with your local authorities to ensure that you are following the correct codes and standards. They may have specific requirements that are not covered in the NEC. Consider joining a professional electrical association to network with other electricians and stay up to date on the latest industry trends and best practices. Professional associations offer a variety of benefits, such as training courses, networking events, and access to industry resources. When working on electrical equipment, always follow lockout/tagout procedures to ensure that the equipment is de-energized and cannot be accidentally energized while you are working on it. Lockout/tagout procedures involve placing a lock and a tag on the circuit breaker or disconnect switch to prevent it from being turned on. Consider using a ground fault circuit interrupter, also known as GFCI, tester to verify that GFCIs are working properly. A GFCI tester simulates a ground fault and verifies that the GFCI trips quickly and safely. This is an important safety check to ensure that GFCIs are protecting you from electrical shock. When working on electrical panels, always wear appropriate personal protective equipment, such as a face shield, gloves, and insulated shoes. This equipment can help to protect you from electrical arc flash, which is a dangerous explosion of electrical energy that can cause severe burns and injuries. Consider using a thermal imager to inspect electrical equipment for hot spots. A thermal imager can detect areas of excessive heat, which may indicate a loose connection, overloaded circuit, or other electrical problem. This is a useful tool for preventive maintenance and identifying potential hazards before they cause a failure. Always keep your work area clean and organized. A cluttered work area can increase the risk of accidents and injuries. Keep tools and materials in their proper place and dispose of waste properly. Remember that electrical safety is an ongoing process. Continuously learn and improve your knowledge and skills to stay safe and prevent accidents. Make it a habit to review electrical safety procedures and best practices regularly.